this computer. One, two, three, check. Testing, 1, 2, 3. Okay. All right. Okay, this is Durwood King, and I'm going to demonstrate a lab that Dylan, Ivey, and Hunter Bruce had wired before the virus came and kept us from coming into the shop for them to test their lab. So I'm going to show you the lab that they wired up. It's an Allen Bradley soft starter, and I'm going to show you the board and the schematic first, and then we'll demonstrate it and do a couple of voltage measurements. So here's their circuit. Okay, that's their board there. There goes their name tag. There's Dylan, Ivey, and Hunter. So that's your board. This is your board here. And what I did is I came in here this morning. I inspected your wiring, and the focal point would be this soft starter right here. It's an Allen Bradley SMC3 soft starter, and it has an isolation contactor here to the left of it. This used as an emergency. If something happens and the soft starter were to fail electronically and stay on, whenever you hit that e-stop, it will cause the isolation contactor to open up, and it would cut power going to the soft starter, which would de-energize your motor in case of an emergency. So the schematic is right here. That's the entire schematic. Now, when I show the video tonight, we're going to go over in detail all the parts of the schematic. And briefly, what I can actually do right now before we start it is I'll do a screen share and walk you through all the parts of that schematic real quick. It won't take but a second to do that. So I'm going to move the camera here. Okay, I'm going to do a screen share and discuss the schematic real quick. Now, so I had the schematic up, and up at the top left, you have a three-phase disconnect with fuses in there, and we have 208 volt AC coming in three-phase. It could be 480, depending on where you are. It could be in the low voltage range. It could be from 208 to 240, or you could have a different model number that may go as high as 480, a different model number of a soft starter. Here you have IC. This is the isolation contactor. It is it's a standard contactor that's there to enable, to put the three-phase power to the soft starter that says SS there. This is the power section, the three-phase section of the soft starter. And so the power comes in from isolation contactor, goes through the soft starter, and the soft starter gives, as the name implies, it gives a soft start for the motor, that it doesn't start out at full speed. It starts out very slowly and then ramps up. So this is a portion of the soft starter right here. It says SS in the dash lines. And then we come down. And then you have a step-down transformer that steps to 208 volt down to 120 for the control section. So let's go down a little further. And once the 120 leaves the control transformer, it goes to an emergency stop. It's a maintain. When you press it, it actually locks in. And it's a push-pull. You push it, it locks in, and locks open. You got to pull it to actually release and reclose it. So when you leave the e-stop, right up here, when you leave the e-stop, then it goes to several places. Wire number 2 goes to a lot of places, which is 120 volts after the e-stop. So if the e-stop presses, you lose everything in here. And so let's take the first place. First place would be, it goes to the solid state to the soft starter to terminal A1, and that's kind of like that will be your coil connection, so to speak, like on a regular starter. So A1 is here; it stays hot all the time. A2 is neutral. So A1 and A2 on a soft starter stay hot all the time, and they wait for a signal coming in from input 1 and input 2 to actually start the motor. So here in the dash lines, you have your stop and your start button. And again, you also have an in-between wire that goes into input 2 on the soft starter, and that is to connect to the internal holding contact within the soft starter. So it has its own holding contact inside the unit that you access at input 2, like you would normally do a standard hardwired physical holding contact outside. It would be, you're using the one that's inside of the soft starter. So when you press the start button, it energizes the control coil inside, and that causes that contact to close, and it gives you a holding feature in parallel with the start button. Okay, so that your holding is still standard, it's still parallel with that start button. When that happens, come on down. The next line here is 120 volt. It's going to an overload fault contact that's also a part of the solid state soft starter at terminal 97 and 98. So everything that says SS, this says SS, that says SS. All of the SS terminals are actually on one unit that I'm going to show you in just a second. That what you just saw, but one unit includes all of the terminals that are listed for SS. That's soft starter. So 120 goes to terminal 97, and if you actually get an overload condition on the starter or a fault, that closes, and you get a yellow light to come on the panel. When the control coil on the inside of the starter comes on, you also get an auxiliary contact that's also in the soft starter. It closes at 13 and 14. It brings 120 over to the isolation contactor, IC, to the coil. And when that happens, IC, we're going to go back up top and you'll see what it controls. IC controls the 3 hard contacts that are right here that actually feed the soft starter power section. So if you lose IC coil, you're going to lose all 3 legs going to the soft starter, and the motor's going to quit. Okay, so that's your safety. Electronic drives, it's a smart thing to put something electromechanical ahead of them as a safety, just in case the electronics fails in this and stays on. You still have a physical contact that you can de-energize, and you have a safe situation to shut down. Okay, so whenever you press the start button and you get the control contact coil pulls in, the auxiliary also pulls in. It brings isolating contactor in, which you saw up top, brings 3-phase to the power section of the soft starter, and also you're turning on a green light on the panel. So when the green light's on, you can assume that the isolating contactor is being energized to bring 3-phase into the starter. And then lastly, the IC normally closed contact means this: if the isolating contactor coil is not energized, if it's not on, if you have not pressed start yet, and this is not energized, then this will be closed, and that 120 volt will run, and it will turn on a red light on the panel showing you that the starter has not been energized, or it's not running. All right, so that's it, and that's a walkthrough of the schematic. But again, keep in mind that everything that says SS is all going to be on the same unit, which is actually 3 blocks on the schematic that show SS. If I back out, if I move the zoom out, then you're going to see that. This is one thing about reading schematics that you have to remember, that up top here, that says SS, all of that plus this SS block and that SS block, every bit of that is on the same unit. Now I'm going to turn the screen share off and go back to the camera, and let's look at the physical unit again. Camera's going to be moving around kind of quick here. Now, so this is the soft starter itself, and all of those 3 blocks that you saw in the schematic, all of them are contained here. You have your power leads coming in top, coming from the isolating contactor. So the main power comes in the top of the isolating contactor, leaves here, circles around and goes back into the top of the soft starter, and then your main power leads leave out of the bottom of the soft starter. These red leads down here, they actually leave it and go out to the motor. There's your motor right there. You're getting ready to see run. And then all of your control terminals that you looked at, your A1 and so forth, all of those are right there at the bottom of it, A1 through 14. So all of that's conveniently located together there. And then you also have something that we have not discussed, would be the dip switches that are on the inside. So inside there, you have some physical switches that have to be set up to configure the soft starter. So let me see if I can put some light on there and maybe help this. That's actually too much. Yeah, that's too much. That's not too bad there. But inside there, I know it's blurry on the camera, but you see the switches that are up and down that are in there. My focus is not exactly right, but you see there's a series of small switches inside there. And you set those up. We're going to go through the meaning of all of those switches here right now. And basically, if you had to change one of these, if you change one of them, you want to use something that's plastic, non-conductive. For instance, like this pencil with the lead retracted. So you want to use something, not lead, but just something plastic to go in there and to flip these switches up and down to you know, up would be on. Like this switch here is actually off right now. Let me see if I can get out of the way here. This switch is down, and then this one is up. Of course, you can tell that much from your view. And you see those numbers that are in there. So we're going to go over, I'm going to show you the data sheet for this. I've also emailed you the data sheet for this SMC3 soft starter that includes the dip switch settings. It also includes the overload adjustment. This is the overload relay built-in that you set, and you match this to the nameplate amps, and then it actually gives you extra percentage to allow for inrush. The LED here is a single LED for run or fault. If it starts flashing, and it flashes in these code patterns, for instance, if you get one flash, if it just blinks one time and quits, and if you only get one blink at a time, then it means overload. If it blinks 2 times, then you have over temperature. If it blinks 3 times, you have a phase reversal. And so all the way through 7, you have another one. You have open load, phase loss, open load is 4. So if it blinks 4 times rapidly and then pauses and blinks 4 times again, then you actually have a open phase, a phase loss on your load. Okay, which could be a wire loose or something like that. So depending on how many times that light flashes here, these codes tell you what that one light means by a series of flashes. If you happen to get an overload condition here and this trips out, if you go above the setting of this long enough, then it's going to trip. If that happens, of course, you're going to get the light's going to come on, and then you can press this reset button here manually. It's a manual reset to reset it if the soft starter does trip out. Okay, so now I'll show you the dip switch settings on the data sheet. I'll do a screen share. So we're flipping to screen share now. And we go from the schematic to the data sheet. And you can check in your email. A couple of days ago, I sent you this data sheet right here, and it's specific for a SMC3 soft starter installation instructions. So it's only 5 pages. It's very basic, and it's got just enough to get you started with this thing. Not a lot of extra stuff. And so Here we have the meaning of the DIP switches. And DIP means dual inline package. It's just the physical design of the set of switches that are in the drive. And as you notice, well, soft starters they're less expensive than a VFD, and they don't have a programming screen, so they cut cost on them for you by putting DIP switches in, not a programming keypad. So here you have DIP switch number 3 down there. If you can make that out, when you look at it on your own, open up from your email, you'll be able to read the numbers better. But switch number 3, it says over here, we have it in the up position for soft start. And then switches 4 and 5, if you see over here, switches 4 and 5, I have them set for initial torque of 15%, which means 4 and 5 are in the down position. So all of this stuff is adjustable by you according to your preferences. And then for starting time or ramping, as you see the graph shows a ramping time there, this is sets how long does it take to ramp from a dead stop to top speed. And I'm choosing 30 seconds here. 30 seconds would be, you have to set switch 1 and 2 and 8. So 1 I have down, 2 is up, and 8 is up. And that gives us a 30-second ramping from still to full to top speed, okay? And then kickstart, I'm not using kickstart. I don't see the point in doing that, so I have it off. That is switches 9 and 10. They're in the down position, so I have that disabled there. And then soft stop, you can make it ramp going down. You can do that, or you can just cut that off and let the motor coast whenever you stop it. In this case, I have it shut off so it'll coast when it stops. You can, again, go in there. If you choose these other 3 settings, then it's going to give you 1 times the setting of your previous acceleration. So, for instance, if you chose for soft stopping, if you wanted it to ramp down, you only have 3 choices. You have 1 times T1. So if you put the switches in this position, 6 up and 7 down on the DIP switches, it's going to be 1 times T1, which is up here. T1 was your ramping up, was your acceleration time. So if you got it set to 30, and then you choose for soft stop, this position here, it's going to be the same thing. It's going to be 30 seconds like up here. But if you choose this position of 6 down and 7 up on DIP switches, it'll be 2 times T1, which it'll be 2 times 30. It'll be 60 seconds on the deacceleration, if you follow that, or 3 times T1, which would be 3 times 30, be 90 seconds on ramping down. I've got it cut off, so it'll just coast when it stops. It's just a matter of what do you want. If you're driving a pump, a conveyor, a press, what are you doing, and what is how do you want the circuit to perform? Then that would determine how you set that. For your auxiliary contact that we're using, then I have it set to normal, which would be switch 14 would be down, and this is optional. We don't have it over here for overload trip class. Trip class is going to be in seconds. So do you want the overload to have a 10-second delay, a 15-second delay, or a 20-second delay? So once you exceed the setting on the front of the drive, when the motor goes above the setting of the overload, it's going to take 10 seconds before it's going to trip. If you set DIP switches 11 and 12 up and down, if you set them down and up, it's going to give you 15-second delay before it trips, and here a 20-second delay before it trips. So if you have something like a punch press, Jamie, if you're listening, a punch press at hog slat, and you got one with a large flywheel belt drive, and it takes it, 15, 20 seconds to ever hit top speed, then you may want to go with a 20-second trip class to give the flywheel time to get up to top speed before it would go ahead and trip. That's a real situation that you could use that for. It's just a timer. How long do you wait before it's going to trip? Your overload reset mode is always best to go manual. If you flip 16 down, if it trips, you do have to manually reset it on front of the drive. If you put 16 up, it's going to automatically reset when it cools down, and that may not be safe. That would only apply to remote situations for remote pumps and things like that people, maybe your manager would say, I would rather have it set auto because the pump is, you know, hundreds and hundreds of feet from the plant, and I would rather it just reset whenever it cools down. But in most cases, people are not going to have it automatically reset. The phase rotation switch, which would be 16, I've got it down. And what that means is it's phase rotation detection is enabled. It's detecting the phase rotation of what's coming into the drive from your power line. If you have correct phasing coming into the drive, then it will run. If you have incorrect phasing coming into the drive, if two of the legs are reverse coming in, it'll detect it, and it will give you a fault on the front of the drive, which means you have to actually reverse the two legs coming in. If you disable that, then the drive it will run regardless of the phasing of what comes in. I have it enabled, and so it's good to have it that way. Then you know it's actually detecting what's coming in as far as phase rotation. Lastly, on the dip switches, you have dip switch 15. If you have it up, then that's going to be where your motor is set up like this. You have three legs going to it. That's called a line connection. If you have this type of a delta motor, that type of a wiring going to the motor, then it would be set to delta at the bottom, that's not what we have. We have a standard line hookup, and that's it. That's your hookups. And I'm gonna stop screen share, go back to the webcam, and now let's see. We want to see it run. Let's see. Let's go back. Camera's gonna move around some. And again, what we just discussed there was all of the dip switches that are behind that door. When you close that up again, they're not visible. You just pop that door open like that, and that is your programming switches right there, or DIP dip switches. That's your reset button. If it trips, that is your setting. Now I've got it set. If you look right there, I've got it set around roughly a little bit over 8 amps, because on the motor, you go to the motor, and the motor is hooked up right now at 208, so the amps are going to be 8.3. So you go straight to the motor there, you get it right off of the nameplate, 8.3 amps. You come over here to the soft starter, and you put it in that range there with a screwdriver. So this is just a little screwdriver adjustment here that can be changed. You always want to dial that in. So if you install a new soft starter, you always want to dial that in to what the motor says on the nameplate for running amps. Based on the particular amps. If you're running it at 230, your amps would be 8.2. If you're running it at 460, your amps would be 4.1. So those numbers, you got to know what voltage you're at to get the right amps to properly set the overload on that soft starter. And then the data sheet says that if you, let me pull it out, it automatically calculates extra amps that you need for startup. So I'm going to find that and show it to you. So it says right here that the trip rating is 120% of the dial setting. So you don't have to multiply the motor nameplates by 125% like the code book requires. The drive actually does it for you. It actually does it at 120%. So what we set that for here, it's going to take that number within the drive. It's going to multiply it by 120% or by 1.2, and that's going to be the real trip setting. So this document is what I emailed you. You need to save that if you think you'll ever use this type of a drive. And there's other information in there as far as the troubleshooting guide. You have a troubleshooting guide in the back there. It's got tips on different symptoms and possible solutions there. So it's a good guide there, and that's the front right there. So when you open it up from your email, that's what it's going to look like. And whatever type of soft start you might have at your location, you can easily download one directly from the manufacturer, right off the internet. Just Google whatever model number it is, and you can have it in just a couple of seconds on your smartphone. Okay, so we're going to start it out, and I'm going to hit the start button, and we're going to focus over here on the shaft, so you'll see the shaft turning. And actually, if you hold on a second, I'm going to mark it with a piece of red tape. So hold on just a second here. One of you mentioned, I think Thomas had mentioned the other day, that he couldn't see that the shaft turning. So let me get a piece of red tape and mark it. Because the video may be a little blurry, you know, on your end. So I'm taking a piece of red tape here. And stick it onto the shaft there. It's probably not going to stick. I don't think it's going to actually stick. So what I'm going to do is get the camera close enough to where I'm sure you'll be able to see it. Now, so you can actually see the keyway in there now. So you should be good to see this. So there goes the shaft there, and I'm going to start it up. Here you go. 1, 2, 3, go. You see how slow it's going? There it goes. So it did have a soft start to it, like we programmed it. And then I hit stop. Yeah, I hit stop right then. It's just going to coast and stop. So it's just freewheeling there on stopping. That may or may not be what you want, depending on your application there. So you see it slowing down. We'll do it one more time, and then I'll get the meter out and let you see what the voltage readings look like. Okay, so it's slowing down. It's just coasting. And then we're going to start out again when it stops. Okay, so we're going to start out again. 1, 2, 3, go. And that's your soft start right there. Very, very slow starting. All right, so there you go. Now, so I'm going to move the camera and let you see the meter. Hey, how you doing? Recording. I'm recording for tonight. I'm recording a soft starter so that they can see it tonight. I can't take it home, you know. Some of them didn't get a chance to do one, so I'm doing this. Okay, so getting the meter set up here. Up and down. Now, so here the meter's auto ranging in millivolts. Let's go down. Let's go up like that. And go in some. You see the MV right there, the meter's actually auto-ranging in millivolts. If I put the leads together, it's gonna go on down to nothing. It's just picking up static electricity out of the air right now. So if you touch the lead together, it gets rid of that. Now I'm gonna go over to the starter itself, and I'm gonna cut the starter off. And I'm gonna put my leads on the starter itself. And when it stops, you focus on this meter here. That's what I've got hooked up here just now. I have a multimeter there. The scope we'll look at in just a second. Okay, so the motor has stopped. And now when you see it start up, you'll see it start at low voltage and then go higher. Okay, just focus on the left meter there. Here you go, 1, 2, 3, go. So now it's reading at 60 volts, then it goes up to 70, and then 80, and then 90 something, and then 209. So the meter started registering at 60 volts, 70, 80, 90, and then all of a sudden it flipped over really fast to roughly 208. 208 is the top voltage there. Okay, one more time. So it's calming down now. And what the soft starter is doing is it's not giving you a different frequency. It's actually doing a voltage reduction. So it gives you a reduced voltage starting, not variable frequency. So here we go one more time. Watch it closely here. Cutting it on now. It went to 60, to 70, 80, 90, and then it flips over real quick over to like 202, roughly 208, 209. Okay? So the way it's doing that is when you look at the schematic, within the soft starter itself, it has, for each phase going to the motor, it has some electronic SCRs in there. The SCRs give you a reduced voltage going out there in the beginning, but after it goes over the ramping period, it actually bypasses them with a standard contact in here. So they bypass the SCRs and go straight out at full voltage. So the ramping at 60 volts and 70 and 80 and so on happens with the SCRs that are electronically controlled. And then it actually cuts these hard contacts on within the soft starter, and you get the full 208 coming in from over here, as you saw. You know, you saw the how the meter was doing, and now we're going to look at this is where we were measuring that leaving here, going out to the motor. So that the ramping is what you just saw there. Now I'm going to show you with the oscilloscope, a digital scope called a Scopemeter, what it looks like out here. Okay, so this meter over here is called a Scopemeter. It's a Fluke industrial Scopemeter, so it's like it is an oscilloscope, but it also has a lot of other features on it too. It'll measure volts, ohms, hertz. It'll give you frequency. It's a very, very nice high-tech meter. So I'm going to put the leads of the Scopemeter over here on the soft starter with it running at top speed. And as you see, you have a nice clean sine wave at 209 volt. This is the same thing that this meter read a while ago. So the digital scope gives you a regular voltmeter reading in AC volts, and if there was any DC, it would show me this other second small display. So it's AC and then DC down here, which there's none present. And it's a nice clean sine wave there. This is the same thing to what's coming in. So that's what's leaving the drive, and I'm going to move it up top to what's coming into the drive. It's going to look identical to it. So that's what's coming in. So what comes in and what leaves the drive is identical at top speed with this soft starter because of these bypass contacts that are on the inside. After the ramping period, it actually shoots around and does the actual identical voltage coming in. You see it appear out here. If you don't get that with a VFD, you get a totally artificial signal out here. You'll find out on the next video. But this is the characteristic of a soft starter, what you would expect on the output. Okay, so I'm gonna put the probes back on, leaving the soft starter. We're gonna cut it off, and you see the voltage going down. You see it going down. It's down to like 6 volts now. It's just coasting, freewheeling, and it's getting way down. And you'll see it actually auto range out into a millivolt range in a minute here. Auto range means the meter actually, when it senses something small, it changes the range to try to calculate what it's actually connected to. So the signal again is dying down, and it's basically nothing now. So I'm going to hit the start button again. Okay, here we go. Watch it closely. What you're going to see is a bunch of jagged lines in here when I start it, and then the voltage up here will ramp up slowly. And when it finally flips over from around 100 and something volts really quick to 208, you'll see it go from jagged lines to a nice clean sine wave like normal. So here we go. 1, 2, 3, go. So you see that the jagged lines in there, it looks like triangles, and then it goes over to that. So it's an unusual looking type of a pattern. Let me see if I can maybe even get, well, there's no sense in getting it closer to that. I'm gonna cut it off one more time. I'm changing the contrast on here so you can see better. So I'm darkening the screen so you can see better. Now you'll see what looks like some jagged, like triangular type wave pattern. And let's go. I'm gonna cut it on again. 1, 2, 3, go. Here we go. So you see those jagged lines in there? And then it switches over to the sine wave. All right, let's try that one more time. I'm gonna cut it off. By changing the contrast on this thing, I made it darker that you can see the details better. So if you'll focus on, I'm going to explain something about the waveform you're seeing here, what you would expect to see. You see it's dying down. Okay, here we go. 1, 2, 3, go. So you see the sharp lines going up, and the voltage going up slowly. Hold on, my multimeter leads were not hooked up very well. Let's try it one more time. Sorry about that. My hands were moving around. Dying down. So I'm going to hit the start button again. Here we go. 1, 2, 3, start. So you see the jagged lines there. And then it goes up to a nice clean sine wave. So the jagged lines, what you saw there was basically this. The SCRs inside of the drive are doing this. They'll cut on for a little period in there and shut right back off. And then they'll cut on a little bit here. They're giving you part of that sine wave. It's called phase angle control is what it's doing. It's so many degrees in this, like that's 90 degrees, that's 0, 90, that's 180 degrees in that wave there. At so many degrees, it actually shuts off. So the SCR lets it get up to a certain, if I quit moving my leads around, the SCR lets it get up to a certain voltage here, and then it actually shuts the output off. And then it actually cuts it back on over here when the incoming power is down. It shuts it back on, so you actually get a little spike in there, and then you get another spike here, and you get another spike in there to where it's actually only cutting on for part of that sine wave. It lets it go up so far, and it says, "Oh no, we're going to shut it off." So it appears to be like a sawtooth wave, like a saw blade, and then over here, the off period is from here to here. It's off, and then it shuts back on here, cuts back on, and then comes down. So it appears to be a jagged, like a sawtooth here, a sawtooth there, and it repeats again. You get a sawtooth and it shuts off, and you get another sawtooth here. So you're only getting a part of the leading and the trailing edge of each wave there as far as your on time. So the SDRs are actually fast switching to, they actually gate and cut off part of that. They only give you the lower part of this. The top part is gone, so it actually goes down, and it's like nice. It's very sharp looking. So one more time, cut it off. Dying down. Cut it back on. 1, 2, 3, go. And you see those jagged lines in there. Anyway, you got the idea. So that's roughly what you would see there. And if you're using a basic meter, a very basic meter like you use here at school, the smaller Fluke, I'll show you that one real quick. So if you're using this meter right here, go off, back on, then it'll read this fine. So it's reading the 211 right there. And if I shut it off, I'm gonna cut it back on. 1, 2, 3, go. You see it read. So you saw it that even a basic meter will do fine on leaving a soft starter. It'll do fine. Now on a VFD, this won't do too good. We're gonna find out on the next video. But again, okay, so that just gives you the basics on what you see and on a basic, an intermediate, and then a scope. Okay, so we're gonna end the video and apologize about the camera moving around so much. But anyway, if you have any questions, you can let me know. And I'll be using this tonight as a demonstration because, of course, you can't bring this stuff to the house where I'm going to be conducting the class from. So I'm going to end it. Thank you for watching. And again, let me know if you have any questions. Thank you. This is Durwood King at Sampson Community College signing off. Thank you. God bless you.